Very good. I'll do a brief introduction, then we can get started. So first of all, welcome to our guests. We're really delighted that you can join us. It's always wonderful when family and friends can join. All right, our next presenter is Andrew Breyen from Nowlin, Minnesota. His hobbies include technology and using his talents of technology knowledge. Recently, especially during COVID, live streaming has exponentially grown. I've helped my home church stream from ground zero, and also have helped Magis Ministries on campus transform our programming into a COVID-friendly event. So that's a quote of his. After college, he'll be joining Best Buy Corporation as an associate digital engineer to solve technology problems and address the key human needs. Among his best memories are College Bound and other peer resource program trips and events. And he especially loved being able to adventure out in a way that may not have been possible without organizations like PRP. Among his worst memories, he quote, "While we sure had a blast sophomore year during the epic cold spell, those 3 days definitely were a challenge whenever I had to leave the building." Andrew will speak to us about phishing with a PH. Take it away, Andrew.
Awesome. Thank you, Mike. As said, my name is Andrew Breyen, and today we're talking about phishing with a P and not with an F. We're going to be talking about how to catch the fish before you get hooked. So today we're going to be talking about what is phishing, what are some of the different mitigation techniques of phishing, how we can detect and filter phishing messages, as well as how detection can be bypassed. So phishing can be defined as a type of cyber attack that uses email, phone, or text messages to entice individuals into providing personal or other sensitive information, ranging from passwords, credit card information, and social security numbers, to details about a person or an organization. A bad actor poses as a legitimate representative from the company, such as from IT services, a high-level CEO, or someone else who should be trusted. In the case of phishing of normal users, these bad actors often pose as a company that the user trusts. This bad actor attempts to extract personal information, and in an increasing number of attacks, financial information as well. This information is used against the intentions of the user or institution and can be extremely detrimental to users and companies. As was previously stated, phishing is an extremely lucrative industry. The phishing industry can cause significant financial burden to national economies. Forbes reported that in 2017, the phishing industry cost American corporations over $500 million. This attack vector is not unique to American businesses. In fact, the Australian Competition and Consumer Commission described in a report that there had been over 200,000 scam reports and reported losses of 340 million Australian dollars. In Proofpoint's State of the Phish report in 2020, over 83% of reporting companies had experienced phishing in some way. This statistic has increased over the years, especially as more and more individuals have had to work from home and therefore may not have as secure of a network at home than in the office, especially for personal email accounts. Due to this staggering statistic, it is integral that mitigation strategies improve. So due to the commonality of phishing attacks, mitigation techniques are rapidly evolving to protect users from the ever-growing threat that is phishing. Mitigation of phishing takes two major approaches: user training and filtering. These two approaches can be powerful on their own, but in order to be effective in thwarting phishing attacks, these two tactics must be used in conjunction with each other. The first one we're going to be talking about is user training. One of these studies that was done by Fairmont State University involving their students, staff, and faculty, and they evaluated how likely different user groups and in what instances phishing messages were most clicked and interacted with. Users were divided randomly into several different training groups, including receiving a long text-based document, a shorter text-based document that included visual examples of phishing emails, a game, or no training at all. The research team sent out over 90,000 simulated phishing emails to 4,700 users. If a user clicked on the link in the phishing test message, that user was successfully phished. After being phished, the user was directed to the training that they were previously assigned, or in the case of the none group, no training at all. After evaluating the results, it was found that 44.3% of users clicked on the links and 18.6% of users provided their credentials. It was determined that from the repeat phish rate of users, that the short text-based document with visuals was the most effective training strategy. The researchers also determined that the most effective time for a malicious message to be sent was in the early hours of the workday, as users usually check their inboxes in the first few hours of work, and because the users may have a lot of messages, they may not be as likely to thoroughly vet each and every one. It was also found that iOS devices were the most likely device for phishing URLs to be clicked on. This statistic brought to the attention of the researchers that there is a great need to secure iOS and other mobile devices on corporate networks. However, user training often is not enough. Every user is not going to scrutinize every single email that comes through their inbox, even if this is the expected policy outlined by the IT department. It's just not a feasible strategy. However, user training does help, but sometimes really clever, malicious messages can trick even the savviest of users. Because of this, phishing detection and filtering must be conducted. Phishing detection occurs on the mail server level, in which every message is passed through a mail filter, not only for viruses and phishing attempts, but also to protect the company from confidential data leaks and other malpractices. Deep learning algorithms can be used to identify these phishing emails before they are able to reach a user's inbox. In this method of phishing detection, typically a logistic regression approach is utilized to identify unique lexical features of a message. Some of these features that are monitored include if the message includes a uniform resource locator or a URL, and if it does, the URL itself, specific words in the URL, and host details including the page rank and its existence or not in a URL phishing black or white list. Over 18 different features were extracted per URL, and when analyzed in a typical deep learning algorithm with a dataset including 2,508 URLs comprised of 1,245 phishing and 1,263 legitimate, this method was able to achieve a 97.3% accuracy rate. Another method of detection involves using naive Bayes, support vector machine, and logistic regression. These three tactics are utilized with 20 to 30,000 URLs using both lexical and host features. These machine learning models are able to achieve a 95 to 99% detection accuracy with an error rate between 1.9 and 3.5%. This method of using deep learning has proven to be extremely effective. However, these tactics often require significant manual effort to be performed on a continual basis, which makes this method not as easy or efficient to use than the other models. In an institutional filtering system, administrators would have to flag new messages as phishing in order for them to be added into this algorithm. Recurrent neural networks, or RNNs, can be utilized to create a more effective and efficient model to detect, flag, and if necessary, remove phishing emails from user inboxes. An additional type of RNN, bidirectional RNNs, are used in this classifier as well. These classifiers are used in conjunction with the two most popular memory cell architectures, LTSM and GRU. Long short-term memory, known as LSTM, is a novel RNN architecture, together with an efficient gradient-based learning algorithm that effectively addresses the insufficient and decaying error backflow problem in traditional RNNs. Gated recurrent unit, known as GRU, is part of a specific model of recurrent neural network that intends to use connections through a sequence of nodes to perform machine learning tasks associated with memory and clustering. Combinations of these memory architectures are utilized to create 4 different URL-based phishing detection models known as LTSM, GRU, bidirectional LTSM, and BiGRU, known as bidirectional GRU. These four classifiers have different memory cell architectures. GRU and BiGRU use a backward direction network to reverse the encoded URL and concatenate the hidden states of the final time steps for both the forward and backward direction network, and provide that to the sigmoid neuron in order to produce a phishing prediction. In this case, a sigmoid neuron is defined for every input. There is a weight associated with this input. The weight indicates the importance of the input in the decision-making process. Non-alphanumeric characters are often used in phishing messages, both in the URLs and in the text of the body. Bad actors can attempt to fool users by adding extra unnecessary dots, hyphens, or other characters into a URL of a phishing site to help them to gain credibility. Because of this commonality, the URLs inside of messages can be analyzed to determine if the message may be a malicious one. This system is useful because it does not rely on analysis of page content itself, as attackers may hide information on the page's content, which may be difficult to detect with other models, such as content-based detection. The results were compared with two other classifiers, such as Gaussian naive Bayes, or GNB, and support vector machine, SVM. It was found that random forest was the most effective at 96.2%, compared to 90.66% for GNB and 92.77% for SVM. Another disadvantage to SVM is how long its parameter tuning process takes, 10 times longer than the random forest classifier. This study concludes that their method of non-alphanumeric character detection for phishing sites gains a 5 to 6% improvement over models without. However, it should also be noted that they state that this model should only be used whenever little to no information is available in a web page. They also noted that their method still has a problem of high false positive rates, which they attribute to their data source. So as good as phishing detection is, bad actors who create phishing messages are always in a battle to break the mitigation techniques that we have in place in order to successfully phish users. By analyzing how phishing detection systems can be defeated, stronger systems can be created, keeping in mind the features that they are likely to defeat more primitive systems. The goal of one of these studies to break the filters was to modify a spam email message such that the modified sample was able to satisfy the needs of a spam filter and was able to bypass the filter. Researchers were able to determine the conditional probability of an email being spam with a mathematical model shown here, where S represents the spam email, H represents a ham email, and P of W and S and P of W and H are the conditional probabilities of the word W. In this case, a ham email is defined as an email that utilizes adversarial tactics in order to bypass a spam filter. In order to modify messages to bypass the filter, synonym replacement and ham word injection are one of several adversarial techniques. A ham word is a word that is not in a database of spam words. The synonym replacement method takes a word from the original message, generates a subset of those words, and determines the best synonym word from the subset to replace the original word. Certain stop words such as the, and it were not selected for synonym replacement, as these words do not change the meaning of the message greatly. Synonym replacement was the preferred method, as replacing original words with their synonyms did not change the overall meaning of the message. Ham word injection worked a little bit differently. Ham words can be injected by a spammer into a message that does not vastly change the meaning of the message. However, because the ratio of words in a spam database decreases as ham words increase, this approach can fool the algorithm to let the message slip through the filter. Another classifier is word spacing. It's an additional adversarial technique that can be used to incorrectly classify spam messages as legitimate. Because spaces are introduced, the text parser of the spam filter may interpret a spam word, for example spam, as individual words, and in this case it would be S, P, A, and M. As a result of this, the spam word frequency is disrupted, possibly allowing the message to get through spam filters. So from my presentation, I hope that you were able to take away a few key points, including that phishing is a legitimate threat to institutions and everyday users, that user training and software mitigation strategies must improve in order to improve the security of users, that classification methods are drastically changing and will continue to change as threats change. Classifiers and detection can be broken easily by sophisticated messages, which could prohibit detection methods from working. Thank you.
Thank you, Andrew. Very nicely done. Question?
I have one. After researching phishing, do you think you are immune to being phished?
I mean, I am one of those people who like goes through and is able to have a pretty good thought about, oh, this is an email from Netflix that, oh, I get a free year for something. It's like, that doesn't seem right. So you just have to kind of get in that mindset to weed them out.
Other question? Yeah. Now that you said that, though, you know, you're going to click on the next one.
We'll see. Well, hopefully not.
All right. Other questions? I have a couple, but I want to let others ask if they have any. Our guests are welcome to ask as well. Please feel free.
Hi, I liked your presentation. I might have missed it. I'm not sure if you meant, or yeah, I don't think I heard it, but I was wondering if, usually like how they get a hold of your information.
Yeah, in large cases, they you can, there's, I don't remember exactly what the website's called, but you can like type or it's called Have I Been Pwned, PWND. You can type your email into that website, and then it will show you all the different times that your email has been leaked, just from like companies having bad practices, and then all their usernames and passwords and everything go out onto the interwebs.
That's interesting. Thank you. I'll probably check that out because I actually have received a lot of these, and yeah, like you said, they're very convincing.
Yeah.
I had a question or two. Are there other questions before I do that?
Sure, I just got a quick question.
Sure.
What about like phone calls? Because I think the most common one now is like getting someone on your phone. I guess I see text messages, but I think phone call is probably the most. Is there like a good prevention method?
Yeah, they call those phishing, like
Phishing?
vocal phishing. But again, it's especially as we have like internet connected phones. Phone numbers can be added to databases that are like, oh, we know that this is probably like when you get a call, it says possible scam risk or something. But yeah.
Cool, thank you.
Yeah, I think on Apple phones, you can block any number that is not an Apple phone or in your phone already as well.
Yeah.
That's how I have mine set up.
You mentioned a lot of the kind of individual side of things, how things could be detected, and what about on the server side? For example, many of us have Gmail accounts. Are you familiar with things that Google itself does? I mean, if they get 1,000 messages that are all the same to a bunch of random people, are they on their side able to detect and protect against that situation?
Yeah, I'm pretty sure like if you as a Gmail user, there's like a report spam button, and then that'll go into their like, hey, Andrew reported that blah 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 at whatever.com is scam, and then if they get a whole bunch of those, that can be just automatically sent to like everybody's spam inbox instead of breaking through.
All right, very good. Well, if there's any last minute questions, otherwise we should probably wrap this up and move on. Anything else? Oh, thumbs up.
Thanks,
Nana. Good job. That's great. All right, wonderful. All right, well, thank you very much, Andrew. And then let's move to the next speaker. Zach, you're up.